Hi all. Okay. Hi all. My name is Anup Rajendra. I work for Stacki as the Director of Enterprise Software Development. And today I am going to be talking about Stacki. How many people here have actually heard of Stacki before? Awesome. So have I. So basically, let's get started. So what is Stacki? Stacki is a very fast and ultra-reliable Linux server provisioning tool at scale with zero prerequisites for taking systems from bare metal to a ping and a prompt. I am supposed to read that out verbatim, otherwise my marketing team is going to shout at me. So I decided to do that. But this actually holds a lot of really important parts about what Stacki actually is. So we are a Linux server provisioning tool. So by Linux, we specifically mean, at the moment, we mean Red Hat and derivatives like CentOS, Oracle Linux, and Scientific Linux, things like that. We have Ubuntu and SUSE on our roadmap as well. So we're going to come up with that in the next quarter or so. But for now, we're basically talking about Red Hat and Red Hat derivatives. By provisioning, we basically are talking about setting systems up with an OS, networks configured, disks configured, software installed, configured to a certain extent. And so that's what we mean when we say provisioning. When we talk about scale, we are not talking about 5 machines, 10 machines. We're actually talking about hundreds of machines to 1,000 machines at a time. So we're actually doing this at a massive scale. And to getting it up to a ping and a prompt basically means you start with nothing and you get up all the way to a working network with your shell installed, SSH is working, so you'll be able to log in and actually use the system going forward. And there's no agent left on the server. There's nothing basically running other than the SSH daemon to actually do all this work. So to give you a little bit of history about the project itself, we have our roots in open source. This is kind of important for me to state, not so much in this community in general, but we've gone through multiple iterations of the software itself. We started out as an open source project out of UCSD called the ROCKS project, and then we went, there was a company that came out of that called Stacki. The initial part of it was basically closed source software that were extensions to the ROCKS project. And eventually we basically went back into open sourcing the core of the software because we thought that would actually drive the most growth for the software itself. We started out in 2000, in May of 2000, developing the software at UCSD. It was a 6-month project that after 16 years we still have figured out. We haven't actually finished it yet after 16 years. So that's typically how most software projects we've actually seen goes. We started with the intention of creating software to help professors install and run their own clusters without actually getting grad students involved in it too much, so that they would concentrate on research more as opposed to system administration. That was the original intent behind it, but it ended up being like this massive thing, massive beast that we ended up realizing we had to take. And we realized there was a huge value in actually giving this out to the world for free and actually making this work. So we have roots in the HPC world, high performance computing, so clusters, modeling and CFD design, those kinds of things. So you will actually hear a few terms through the presentation, things like front end and back end. Those are terms that we usually come up with in the high performance world. But if you hear front end, some of the terms we use interchangeably are front end, management server, boss, head node, things like that. And then for back ends, yes, you had a question.
So when you say the modeling,
different kinds of applications in the HPC world. Yeah, 3D modeling was definitely one of them.
Physics simulation?
Yes, physics simulation. We've actually got a lot of people who actually use physics simulation under the...
So cool.
Yeah. Yeah, so the thing is that this is the infrastructure software that allows you to set up your system so that you can run physics simulations on it.
That's so cool.
Okay, good. I'm glad you like it. So again, like I said, we have roots in the HPC world, so you'll hear a lot of terms going through the presentation about what we different terms that we've actually used through our history. So getting back to the problem at hand, what problem are we actually trying to solve with this? At the atomic level, in a sense, you're solving the server provisioning problem. So this means you have to actually, when you get the system from Dell, HP, Cisco, UCS, white box vendor of your choice, what have you. You basically rack it, connect network to it, connect power to it, you turn it on, you actually have to do something with it. So to actually make it usable, so you have to do OS provisioning, disk configuration, and by disk, I actually mean disk controller configuration. How many people here have used LSI controllers or HP Smart Array controllers? And how many of you have felt the pain of configuring it? All of you. Yes, all of us. So there was one of my colleagues actually did a count, and to configure the LSI controller on one machine, to configure a bunch of RAIDs through the BIOS, it took about 80 keystrokes, and that is kind of on the minimal side. So that is on a reasonably uncomplicated setup. So that's something that actually needs to be solved as a problem. So that's kind of where we come into where we do disk controller configuration as well. Partitioning is another important example. Network configuration, set up your IP addresses, routers, gateways, or what have you. Doing services configuration. So when your system's actually up, you actually have to configure services. Turn on SSH, turn on DNS, DHCP, blah, blah, blah. Do application deployment. So obviously setting up on a system is not enough. You want to do physics modeling, you actually have to put the application on top of it. So you have to do that, you have to actually configure the application, and you have to do lifecycle management of this particular host. So over time, how do you do patching, how do you do updates to this machine, and things like that. But of course, this is just one part of the problem. The second part of the problem is data center provisioning, so of which server provisioning is just one part. So you're doing one server. Now, all of a sudden, you have to do a whole data center of these servers. So when you get into that scale, you're dealing with heterogeneous hardware. Different makes, different models, different architecture, Intel's versus AMD's. Not that that makes a huge amount of difference, but it's still enough heterogeneous. The infrastructure is still heterogeneous enough that it can actually cause all sorts of different problems. You're dealing with complex network configurations. You have all your different interconnects, IBs and Mellanox and the 10 gig Ethernets, which are pretty common this point right now anyway. But that's just the hardware layer of it. In terms of actual networking protocols themselves, you have to do bridging, bonding, VLANing, combinations of all these things. So, and this is really common in most modern data centers. When they set up systems, they actually do all these things to kind of keep their infrastructure, secluded and secure. So these are some of the problems that we actually are trying to solve. This is the example of a very, very simple network architecture of a cluster. So you have one front-end node, that's your management node, head node, whatever, connected over a network to a bunch of backend nodes. These are your worker nodes. These are the ones that are actually going to be doing all the work. And they're all connected over a simple fabric, basically a single Ethernet connection, and then they're all connected on one switch. This is one example of what a network architecture looks like. Gets a little bit more complicated. You have two networks. The front end is connected to a public, whereas it's also connected to the rest of the backend nodes using a private network. This was the only architecture we used to support during our Rocks days for a very long time, and then it kind of morphed into when we started seeing how people actually use their infrastructure. We realized we had to adapt it in different ways. So this is what so this is another example, and finally this is the third example of a data center architecture. Super complicated networks, multiple networks using DHCP helpers to actually route traffic through multiple gateways. Every rack can be its own subnet, things like that. So these start to get into really, really complicated network scenarios. So this is another example of how complex data center networks can be. It is not enough to actually solve those problems. It actually is challenging to solve that particular problem quickly, correctly, consistently, and repeatably. So you don't want to be waiting a month to actually get your systems up and running. You don't want to go halfway through your process and then figure out something went wrong. You have to now go back and change everything. You want it to be consistent, which means you actually that means every component in the system actually is aware of and works well with everything else in the system. And you want this to be a repeatable process, which means if something happens during deployment, you should be able to go back and repeat all the steps and get a working correct system. This is actually one of those important challenges that you have when you're trying to solve all these problems. So how do we solve the problem? This is around the time I actually start off a demo. So we have a little time, so we can actually do a demo right now. What I'm going to do is I'm going to do a simple installation of the front-end node itself. And if time permits, I'm going to show you how the back-end nodes also get installed. So I'm using VirtualBox for this demo. It's a very simple system. Obviously, I'm sure most of you have used this by now to just do a lot of testing. It's a very simple setup, single network, about a gig of memory, about 40 gigs of hard drive. So the requirements for, especially for the 6 version of Stacki, is kind of low. If you're working with CentOS 6 and 6.x series, the requirements are actually quite low. So so this is what I'm going to work with. As I mentioned, single network and a pretty small hard disk and a pretty small memory footprint. Let's get started. Okay, I guess I should understand how this actually works. There we go. So this is the first screen that you're going to see when you boot up. So I loaded an ISO through VirtualBox, booted it up. This is the first screen you're going to see, and I choose to install from DVD because that's what I've got in there. It looks like a pretty standard Red Hat installation, and that's because that's exactly what it is. It's basically using Anaconda underneath. So we've actually hacked the installer to kind of take care of a lot of these problems. So this is, yeah, so basically all it's doing is it's booting up, initializing your hardware, configuring your networks, doing the standard Anaconda installation that you see through, and then somewhere along the way you'll see that it actually breaks off from the standard and kind of goes into our parts of the installer, and this is where it happens. So, all right. So the first thing you're going to see is obviously what your time zone is. I am going to choose Los Angeles because I'm from Southern California. I'm actually from San Diego. We all work there. So that's kind of that's why we choose LA. I'm sure if we look through it, we'll see Seattle somewhere, but we're not going to do that now. So then it's the networking screen. This is again pretty standard information. This is something that you're going to have to do for any machine that you set up in your data center. So for here we do Stacki demo2.stacki.com. Choose your Ethernet device that is going to be your primary network. Choose 16 255 gateway 10031 DNS. Use Google always. Google is your friend. Choose your root password. Partitioning. So in this case, for the sake of expediency, we're just going to choose automated partitioning, but you can go through manual, and when you do that, it actually drops you in the standard manual installation, manual partitioning screens from Red Hat, and you can do all the configuration that you want. So choose choose automated. It gives you a list of what are known as palettes. I'm going to explain palettes in a little bit more detail as we go through the presentation, but for now, all you need to know is a palette is the atomic unit inside of StackIQ, which is Stacki, that allows you to sort of configure so that gives you basically configuration data and RPM data together. So if you have an RPM is basically just binary data in it, right? You have a bunch of files in it, executables, scripts, and things like that. You can sort of append some postscripts and prescripts to that, but that starts to get a little complicated, especially when you're dealing with a huge set of RPMs. So what we've actually done is created this logical unit of a set of RPMs and then configuration that sort of applies around it, and that's what we actually call a palette. Now in this particular case, we have two palettes. The OS palette, which is basically a subset of the standard CentOS distribution, so things that we think are absolutely necessary to get a cluster up and running, and then Stacki, which is our secret sauce, which is basically all the palette, which is the palette that we create. This has things like the libraries, the command line infrastructure, the database setups, things like that actually are necessary to bring the Stacki system itself up and running. So those are the two palettes that we have, and those are the two palettes that we need. By the way, just an aside, when you're going through a standard installation, you can actually substitute the OS palette with a full CentOS or a full Red Hat or a full Oracle Enterprise Linux distribution as well. So it totally depends on what if your company has a specific policy about using a very specific OS, a very specific supported version of the derivative, you can use that as well.
So if you just select the OS and you have Ubuntu or something like that.
Exactly. So you can actually even create an ISO with Red Hat on there. So we've done that for so many of our customers, and as part of standard operating procedure, we do that. Yeah. So the OS palette actually was created specifically for this demo because with the OS palette, it's about 1.2 gigs. If I put the whole Red Hat thing on there, it's about 5. So I don't want to have to carry it around that much. So I put a small one in there. And then you select all, say continue. You look at the summary. If there's something that looks wrong, you can go back and change it. And you say install. And you're pretty much done at this point. This is around the time you actually walk away and get yourself a beer, coffee, whatever you want. But this is, it's going to go through, again, a very standard Red Hat installation. It'll look exactly like that. There are a couple of extra screens that you will see, but nothing more that you actually have to touch on the system until it actually reboots. So it downloads the palettes from the ISO that I'm loading, so it's not going over the network or anything right now. So everything is self-contained on that 1.2 gig ISO. It's going to so it formats your disk, it actually puts all the bits there and then installs from itself. So that kind of makes it really easy for it to, and really lightweight as a footprint. Yes, go ahead.
When you're creating these palettes,
yeah,
which your company has created, you have like testing features where when you add your different RPMs inside that palette, can you test them without having to install?
So typically our model of testing itself is the installation, because that's kind of what we are, what's the expression that I like to use? It's basically that is our benchmark for testing. Meaning if it passes muster for installation, that means it works. So typically I like to quote Linus when I say something like this. There's a really famous saying where he says, if it compiles, great. If it boots up, even better. You can just stop after that, right? It's like that for us too, in a sense. If it builds, it's awesome. If I can install a machine with it, I'm not going to worry about it after that point. Everything else is gravy from that point forward. Obviously, configuration has to be honed as you kind of go forward and make sure that everything works correctly. But I know we are not going to have time today to show you that part of it. But basically, we have configuration data in the form of XML that allows you to say what kind of packages you want to install, what configuration you want to put down on the system, what kind of files you create, and all that. So yeah, go ahead.
So are you just leveraging the comp system?
We are actually leveraging comps.xml. We are actually leveraging the Kickstart framework as well. Yeah. So heavily, yeah. We are basically piggybacking on top of Anaconda at this point.
I'm Brian Lane.
Okay.
I work on the Anaconda installer team.
You do? Okay. So in that case, this will look familiar.
This makes me very happy.
Oh, I'm glad you like it. I am tremendously happy.
Have you looked at RHEL 7?
We have, yeah. We actually have a RHEL 7 distribution. I didn't bring it because because we're going through a release cycle now, so I don't know what state those bits are in.
We've done a bunch of stuff with the add-ons.
Yes. Yeah. We've been using include directives in Anaconda for God knows how long. Yeah. We actually put in a whole bunch of Python libraries into Anaconda as well on the site using updates and installer.img and all that. So yeah, we've hacked the installer pretty heavily. Yeah. Go ahead, sir.
Yeah, so I know, not to offend anybody here, but we do standardize on the Bluetooth for some reason.
Okay. Yeah.
But does this also, when it does this install, does it also take care of all the dependencies and everything that's required?
Actually, at this point, again, even that sort of comes under the Anaconda umbrella, which means with this, Anaconda uses Yum to actually do all the installation. And that we just piggyback off of that. We have this whole repository there. We point Anaconda to it, and we say, these are the packages we want. You take care of everything else.
Oh, so the install is based...
the install is doing exactly what a standard Red Hat install would do. Yeah. It's going to go through its own system just to get all the installer... I'm sure Brian Keogh can speak a lot more about the installer than I can. But yeah, so that's kind of what it is. And again, this looks like a very standard Red Hat install. We'll just let this continue for a little while we kind of... If I can find my mouse... There we go. Alright, so we'll just let that go in the background and we'll continue the presentation. So going back to how we actually solve that particular problem, and this is how we do it. We basically do it by taking control of the entire stack. We modify the installer to basically say, have those checks in the middle, which basically allow you to configure all sorts of different pieces of information. We have a parallel package sharing installer. So what that means is when you install your backend nodes from a front end, what it's actually doing is it is taking, so we have a BitTorrent-like installer. In fact, it is actually inspired by BitTorrent, where there's a service running on every single installer which actually is doing packet sharing. So when you have 100 machines installing at the same time, they're not all hitting one machine on the front end to actually get all their bits. They're actually talking to each other and sharing packages as they go through the installation. So this makes it very, very easy for us to actually scale the installer to a significant extent. So that's a packet sharing installer. We have a database maintained on the front end which contains information which keeps persistent data about the system. We have a command line to interact with the system itself. So Stacki basically is the database plus configuration plus scripting. So we have a command line that actually talks to the database and kind of configures your system the way you want it to be. And finally, we have dynamic kickstart generation. So Anaconda basically uses kickstart to do its installations. And every time a kickstart request comes to our Stacki server, we actually generate a kickstart file just prepared for that. So there are no pre-built kickstart configuration files. Everything is templated. Everything is fully dynamic and extensible. So we do that by that's how we actually solve taking care of the entire stack. Some of the other things that we set up once the machine is up, we set up services to actually help us boot up and install the backend nodes. Set up DHCP to give you MAC address to IP address mapping. Set up TFTP to serve our Pixie files. Apache we install and configure to make sure that we can actually serve out the kickstart files over HTTP. And DNS, this is optional. It used to not be optional. We actually required us to be the DNS server for the environment. We've actually made that completely optional now. So if you have a separate DNS server running in your environment, you can actually use that and point your system to that. And finally, we also set up some services to actually give you access to the backend nodes once they are up. So we do SSH key management, where we actually can actually track some of the keys that need to go on, not need to go on the backend node, but root keys that actually allow you to log into backend nodes without using a password. We also have a parallel execution shell that's sort of built around SSH. So think about it as Ansible Lite, basically. So something that actually allows you to log into a machine without using a password, but also at scale. So you can log into hundreds of machines and run a particular script at a given time. So how does this look in an actual setup on an actual machine? Stacki is the part that takes care of the entire bottom layer of that screen, which is we configure the OS, we configure the disk, both controller and partitioning, we configure the network, and we configure the services. Everything else on top of that is something that usually we have seen administrators add up on their own. We have, obviously this is an open source conference, so I'm not going to make a sales pitch here, but we do have things on the side that allow you to do it, but usually those are kind of paid efforts. So this is how a standard Stacki install is going to look. So this is, as you were mentioning earlier, the physics modeling software would sort of go on top of at the very top layer, and then you have DevOps tools like Ansible, Salt, Chef, Puppet, what have you, that actually do the DevOps and configuration as you see fit. So this is how it's going to look. A reiteration of the screens that we just went through. Obviously choose a DVD, select time zone, do networking, do root password, do the partitioning, select your palettes, look at the summary, do the install. And that's it. That's basically how you do a front-end installation. Now, let's actually go and check what the state of our install is. Our front-end is up and running. So let's see if we can log in. If I can find my mouse. There we go. So we're actually logged in. So we have a command line utility called stack. So this is a little bit of a digression here. So basically I wanted to talk about how you interact with the Stacki system itself. And we have a command line utility inspired by, how many people here remember track? Does anybody remember track at all? Okay, good. We have a bunch of people. So track has a really nice command line that actually allows you to sort of configure all sorts of different parts of it. And so that was the inspiration for Stacki, for the command line in Stacki. So we took that and we said, okay, we can make something look like it, and we basically created this command line utility, which is verb-based. So you'd say something like stack list host to give you a list of all the hosts that are part of your system. At this point, we just set the machine up. There's nothing else except the front end itself. So that is the only one it knows about. We have a whole bunch of different commands that we'll actually go through as we kind of go through this. So yeah, we'll get to that in a second here. So obviously, you set up your front end. Now you want it to actually install backend nodes, because what's a cluster without multiple backend nodes? So how do we go about doing that? Again, to reiterate, we built up services on the front end and set up SSH. Now you actually have to go through the task of adding hosts. Now to add hosts, we actually have two different methods of doing it. I'm going to talk only about one of them again for the sake of expediency today. The first method is called discovery mode. Discovery mode is basically what you use if you have a very controlled network environment. So you have one switch, or even if it's a bunch of switches, they're still on a single flat network. You're not running a DHCP server anywhere else, so you have a really simple setup, and you don't want to go about assigning host names and IP addresses manually to every single host. You just want an automatic assignment. That's when you would use discovery. The advantages are you have no reason, you do not need to know about the MAC addresses that are part of the system, that are on your backend nodes before you do it. It gives you automatic and sensible host name and IP address assignment. So when you add a host, it actually looks at the subnet that the front end is in, calculates the greatest one available, assigns that to it, assigns it an automatic host name, something like based on appliance. So if you're installing a backend appliance, it's going to call it backend 00. You know, the 0th rack with the bottommost, this one, that's the first one you install. So it does a lot of these automatic name and host name and IP address assignments. The disadvantages are it's automatic and sensible. The problem with automatic and sensible is if you are a control freak, you're not going to get your way. It's going to do something that it thinks is sensible, and that will work in a lot of small cases. But in a big company where you have hundreds of machines or thousands of machines, where you want to control every single aspect of this assignment, that will be a problem. That is actually a disadvantage. So another disadvantage is if you have really complex network setups, we will actually have to do all these network configurations post-installation. Yes, sir?
For the automatic and sensible stuff, can you change the naming conventions?
Not beyond a certain point. You can actually say something like base name. So instead of calling it backend 00, you can call it something else. But the template for that automatic assignment is still pretty fixed. Yeah. Usually, this is actually why in most cases we don't recommend it anymore. This used to be the default way of doing it for the longest time. But now, as we kind of see how people actually use this, and when you see how control freaks system administrators really are, you really want them to give them an option of doing exactly what they of calling their host exactly the way they want it. So how does this look? How does automatic assignment actually look? There's a command in Stacki called insert ethers. You open it up, you run it. This is the screen you're going to see. It allows you to look at the appliances that are available. By default, we only ship with one type of appliance called a backend appliance. You have a front end also, but we obviously are not going to install any of them, so that's usually never listed here. You get a backend appliance. You select that. It shows you an empty list of machines that were just added. You power on your node. It DHCPs out. It does a PXE request. And then then the interface actually sees it, adds it to the database, assigns it an IP address and a host name, and then gives it back its kickstart file. The second one is what I'm actually going to be talking about today. Now, before you guys, so this one is called the host configuration spreadsheet method of doing host configuration. So the idea there is, before you say spreadsheets are so non-GNU, which is absolutely right, what we saw in most corporate environments is everybody maintains their infrastructure information in Excel. This is something that just blew our minds. We're like, how can you guys do this? And then we saw what they were actually doing. They had a huge spreadsheet with a whole bunch of host names in there, IP addresses, MAC addresses, how they're networked together, what the switches are. All that configuration was actually maintained in a spreadsheet. And what they would do is there was a guy who would look at the spreadsheet on one side and type commands on the other side, making what was in the spreadsheet, putting what was in the spreadsheet into their system. So when we saw people doing that, we're like, well, this is what it looks like in most places. We might as well just take it in. So we decided to actually remove that person from the middle. We defined a format for CSV files. Again, 20 years old, but it's a new hotness now. We defined a CSV format and said, if you put your spreadsheet in this format, we can import it directly into the system, into Stacki. You don't have to and the advantage here is if you make a mistake in your spreadsheet, change the spreadsheet and re-import it again. No problem. You just keep doing it over and over again. Mistakes there are not going to completely break your system anymore, basically, is what I'm getting at. Again, the advantages of this are you have complete control over your host name and IP address assignment. So you basically define it exactly the way you want. You define what networks they belong to. So you can actually control all those things. Very easy to make changes. As I said, you make a change, re-import it again. That's the new state of the system. Fits very well with existing data center management processes. This is what I meant when I said there is already an Excel sheet in every company that actually maintains this information. Put it in a certain format and make it usable. Lots and lots of error checking. So when you actually import a spreadsheet, we actually do a lot of error checking to make sure that your IP assignments are sort of sensible in the correct network spaces. They're named correctly. If you've missed out host names or if you've missed out interface names, it'll warn you about all those things. There's a lot of advantages to that. The disadvantages are, the first time around, it's actually pretty tedious. You actually have to create your spreadsheet first, so it's a little bit of a headache. But again, it's only once. So if you and if it sort of fits into your processes already, you're going to do it anyway. So you might as well just bite the bullet and do it the correct way. It also requires you to have prior knowledge about MAC addresses, IP address assignments, and physical locations of the machines themselves. So where in your data center that actually sits, what the rack is, what the rank, we call it rank or position. So where in the rack itself the machine sits. So you need to know a few of those things beforehand. But again, you probably already know this because your vendor gave you a file that said all these things. So yes, you had a question?
That's what documentation is for.
That's exactly right. So what we're actually doing is taking the documentation and making it part of the process itself. You're absolutely right. That is exactly what it is. It's documentation. So if you could take documentation, put it in the system without having to type it, it sort of gives you the ability to actually change documentation and make that a new state of the system. So that's kind of the advantage of this. Go ahead.
So when you import that Excel file, how does it fail? Does it fail?
It fails very verbally. Okay. It tells you exactly what went wrong. Okay. Yeah, it fails very noisily. It's something we have to actually fix. It's not something I'm very happy about, but still. Yeah, it shouts at you. That is what a host configuration spreadsheet actually looks like. So in this particular case, we've got Stacki demo. In fact, it's the same. It's the spreadsheet from my previous demonstrations. So I've defined two backend nodes, appliance backend, defined the default interface for these machines. There are only one, so I don't need, that's not really an important part here. I gave it the IP addresses, gave it the MAC addresses, gave it the interface names, what networks they belong to, and then you go from there.
Just very curious, what's the default column?
What's the default?
Yeah, column.
Oh, the default interface.
Oh.
So if you have multiple interfaces on a single machine, you define one of them as a default interface. Okay. That's what it is. So how do you do this? You save your spreadsheet as a CSV file, put it on the machine, import it, and you're pretty much set the hosts to actually do an installation, pixie boot all the backend nodes, and you're done. So let us actually see how that looks. So let us actually put the file on there. I have a demo file here. So let's do okay. So let's do that. That's basically a repetition of what you just saw on the slide. It doesn't have the Stacki to demo line because I try to move this particular CSV between different front ends. Whereas I'm doing the demos, that's why it doesn't have that particular line, but it has all the other stuff in there. So now all I have to do is import it. You saw the output of stack list host first, so now I do stack load host file equals Stacki demo.csv. Waits for a couple of seconds, puts all the information in the database. This is another important part, is we actually check this into RCS on the front end itself. So the advantage here, I know RCS is old, but the advantage here is you actually RCS only in that directory, which is why we use RCS, because you don't have to have this whole setup. The advantage of this is, as you make changes to your CSV file, you check them in over time. So you can track the progression of when things finally broke, and you can kind of roll back to an existing known good system. So now we've imported that. Let's see what it looks like.
So you can actually roll back to a prior.
So the way you roll back is you basically, you can remove all your hosts and then re-import a known good spreadsheet, and then it'll actually repopulate everything. If you don't have, sorry.
Rollback built in, but it gives you the data you need, so you can.
Yeah, exactly. Well, what it actually does is it gives you enough information and it gives you enough hooks so that allow you to sort of clean up the system as you see fit. But the important part of that is you have history about how that particular file changed, and so you can sort of track at what point maybe something bad was entered, like an incorrect MAC address or a repeated IP address or something like that. So that's something you can do. So we see that the nodes are now added onto the system itself. We can actually look at the interfaces also. So it gives you the actual MAC addresses, what the IP address assignments were. Everything that you saw in that CSV file is now part of Stacki. So now I'm going to, if I can find my mouse, I'm actually going to, is that minimized? There we go. All right, I'm going to start these two machines. Actually, let me start one. Oh, there we go. So it starts off an installation, does the Pixie boot, DHCP, blah, 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 all that. Oh, I actually forgot something. So this is actually starting a standard CentOS boot up because it already had something on there, and I forgot to do something very important. All right, so the thing that I forgot to do, that I forgot to tell you guys about, is something called a boot action. So right now, Stacki is in the mode of saying that the backend nodes are only going to boot from themselves, and the way it does it is can be checked by this command. So when I do stack list host boot, what it's basically telling me is, according to its internal configuration, the backends are set to boot from their local drives. That's what OS means. But I actually want those machines to install. By the way, this is the default when you do an import on using a spreadsheet, and this is very, very intentional. The intention is, do not destroy the system. The intention is, do not inadvertently completely destroy all your data. So when you import it, you always do OS you always let it boot by itself first. So if you want it to reinstall, that has to be a very intentional act. So let's actually make that the act right now. So I do stack set host boot backend, which lists all my backend appliances, so I can actually name all these things using appliance types as well. Say action equals install. Now if I recheck, it tells me the machines are actually now going to be installed the next time they reboot. So let us do that. Okay. I actually don't know where my host is. There we go. Okay, that's back in 0, 0, right? So now let's do. Let's reboot that guy. See what happens. So boots up. Obviously pretty standard stuff. DHCP's out. Loads an installer. Go ahead.
So if you had other machines that are already up and running, and someone decided to reboot one of those, after you just changed all the backend install, would they go back and wipe out?
Yes.
Okay.
So you, as the admin, will have to be very careful about when you do that. Yeah.
Yes.
Yes. So my favorite quote when it comes to these things is, a computer is going to only do what you tell it, not what you want. Yeah.
So you can granularly select which?
Absolutely, you can absolutely do that. By the way, this is now going off an installation. I'm going to start the second one also. It is probably going to. God, I can't see my mouse anywhere. Oh God. Okay, so this one's going. This one's going about its installation. I'm just going to minimize this as well. I'm going to start this guy.
So you could have just as ballsy like just had 0 boot and stuff or had set 1 to install. Had 0 to boot or something.
Yeah, I could have done that. Well, yeah, I could totally have done that. Actually, let me show you that also. So, there we go. That's, I think, my front end. No, that's not it. That's not it. That's it. Finally, there we go. Finally. All right. So now I can actually do stack set host boot backend 00 action equals install. Yes, I can make it very granular. Yes, go ahead.
So after those re-provision, does it automatically set them back to OS?
It does. It absolutely does. And again, what it does is basically one of the last things that it does when it completes its installation is send the message back to the front end and says, "I'm done. Reset me back to OS," and that's what it'll happen. That's what'll happen. And I will show you guys that in a couple of minutes here.
Does it allow like regular expression, so you can set up?
To some extent, yes. But I am very hesitant to use regular expressions when it comes to these things, because the reason simply being it is a system installation software. So when it destroys things, it actually is pretty. It is pretty robust about its destruction. So there is no recovery from that. So you always want to be super careful about it. And we've had like big name clients whose admins were not paying attention who did this. You put a space in the middle, and it's like the RM-RF story that we all heard about recently. And I don't know if you guys know this, but there was a guy in England, a sysadmin, who wiped out his entire company.
He didn't actually.
He didn't? It was a rumor?
It was a hoax.
Oh, it was a hoax?
He
It was a
doing
great
on-
story.
Well, he said he was doing it on CentOS 7.
Yeah.
Do RMRF on your CentOS 7. It says no, you have to pass the first.
I think what it was it was actually RM-RF with variables in there. But yeah, you're right.
Well,
If there's a hook there that
they tracked him down and
Yeah.
figured out that
he was lying.
Yeah.
Okay.
It was part of some stupid viral marketing.
Got it. That is great viral marketing. I gotta use that.
Yeah, if you're using the
Go ahead.
Ubuntu Linux,
Uh-huh.
you can't remove root without telling it that you actually
Want to remove root? Yeah, that makes a lot of sense. Yeah. Go ahead.
So we notice that these are installing.
Mm-hmm.
If you, for example, want to change the RAID card configuration for LSI,
Yeah.
is there a config file that you change that it pushes to?
I'll actually cover that in a couple of seconds
Because
here.
those are all the details
Yeah,
you want to do.
yeah. No, absolutely. Yeah, I'm actually going to cover that in the next few slides here. So we'll let this guy go about his installation. We'll just leave him as is. So just to go back to this. Jesus. Okay, there we go. Finally. All right. So the way we can actually do this really fast is, as I mentioned earlier, we use a BitTorrent-based installation system, package installation for package sharing. So the front end is not constantly burdened. Packages are shared between the backend nodes directly without actually hitting the front end all the time. And this follows the it follows the BitTorrent protocol very closely, in the sense that as you have more nodes finishing up installation and going into a 3-boot cycle, that drops off from the pool of available hosts. So it still will go back to the front end occasionally, but it's not always. So that's kind of how we are able to achieve that scale. To talk a little bit more about advanced networking, this is the example of a much more complex host configuration spreadsheet. This is something we actually use at our data center every day. So the way we do this is we define the nodes, we define the IP addresses, host names, all that. We also define something called a boss column, which basically says this is your front end. So this is something we actually import into every single every single front end, and then just run it, and then it becomes part of that host's configuration. So a little more advanced networking, we can again support bonding, VLANs, bridging, any of the combinations that we about. Yes, go ahead.
There's only a single front end and they don't talk, right?
I'm sorry?
If you have multiple front ends,
Right.
do they talk?
No.
Do they config?
It's every cluster is its own front end. and that's it. So, and that was actually that's a really good question, and the reason is we've had that particular question from other people also, and we kind of thought about it. We realized that was a very intentional act, meaning you need to have a hook. So we don't have a hot HA or anything like that because this is system provisioning, not necessarily system management. I mean, there is a lot of system management involved in it, but it's mostly provisioning. So the way we set up clusters is you should be able to take the front end out of the picture when this cluster is running, and nothing should happen to it. You only need the front end for installation and provisioning. So that's a very intentional act. So so that's actually why we have this concept of one front end per cluster as such. So so when we get into advanced networking, to continue, we can actually support multiple subnets using things like DHCP helpers. So we can actually manage hosts in multiple data centers from a single machine, which is something people have actually asked us about in the past. So these are some of the things we can actually support. Disk configuration. This is what you just asked about, the disk controller config. So right now, we can actually support two of the major disk controllers, the LSI mega RAID controller and the HPSS controller. The LSI mega RAID controller actually has multiple variants. Intel, Dell, Cisco, they're all pretty much rebrandings of the same LSI chip. So anything that actually supports the store CLI and the mega CLI command, we can pretty much wrangle. And then finally, you have the HP Smarter RAID controller as well, which we support. We have RAID supports, hardware RAID supports for 0, 1, 5, 10, 50, 60, etc., and the 1+0 that HP has. And we can also and we actually can configure all this using the same command line utilities that we have. And in this particular case, this is what a disk controller configuration spreadsheet looks like. Now, the saying around the office is, if you have a hammer, every problem starts to look like a nail. We saw that the spreadsheets were a really, really good way of actually solving the host configuration problem, and we said, why not just do everything with it? So we decided to do that. So I know it's like the perfect computer science story, right? You're like, you look at a problem, you're like, hey, that looks like I can use my hammer on that little nail, so let me do that. So so we came up with this disk configuration spreadsheet. So instead of having to go through the LSI BIOS to configure your controller, or instead of having to actually run a whole bunch of LSI, the store CLI or mega CLI commands, what we did was we said we are actually going to put the configuration that we want in a certain format, import it, and have that be the way the disk is actually configured, the controller is configured. So in this particular case, what it's basically saying is, we want the global configuration to be slot 0 and slot 1 should be rated 1 together. So if you look on the left side, it should be rated into a RAID 1, and then then everything after that is going to be in JBOD mode, basically a bunch of RAID 0s. Backend appliances which override what the global config is. So if you have an appliance that doesn't have its own configuration, it's going to go with whatever the global is. You're going to have a bunch of you configure the backend appliances in a certain way. So in this particular case, RAID 1 for 0 and 1, RAID 5 for all the other disks with a hot spare, and then you actually get to do it at a much more granular level as well, which is on a particular node. So you actually define this massively complex RAID infrastructure, because we have this machine. Node 221 at our data center basically has about 26 hard drives. So when you want to wrangle something like that, you really want to be going through something like this. You don't want to actually, you don't want to be configuring individual hosts, using commands like that. So this is something we actually use on a daily basis. The second one is disk partitioning again. By default, if you choose automatic partitioning, we do sensible defaults, and everybody has a different definition of what sensible is. For us, it basically means a 16 gig root, 16 gig var, and then everything, and about a couple of gigs of swap, and then everything else is basically set up to be something called an export or a state partition, so that you can use for whatever you want. But obviously, not everybody likes that, so we have the ability to actually define storage partitioning also very, very granularly. We have support for multiple drives, multiple file system options, mount options, software RAID configurations, and we can actually do every single one of these things again using spreadsheets. And this is what a disk configuration spreadsheet is going to look like, and this should look really, really straightforward and familiar. Yes, go ahead. Yes, I don't know about encryption, but I know LVM is fully supported. Yeah, I have to go back and look at encryption. Yeah, I don't know the answer to that. So this is basically what a typical storage partitioning spreadsheet looks like. Again, you import it using the Stacki command line, and you go from there. I'm actually going to stop here because this is now going to start getting into a software footprint, and I know we're almost out of time. We just have another 10 minutes. I want to pivot back to the demo for a couple of seconds here. So both my backend nodes are up right now. So let's see. Okay, so all my backend nodes are up. If I do stack list, oh, actually I have to come out right there. As you asked earlier, it's been reset back to OS. That's why when they rebooted, they basically went back into booting by themselves. Now, if I want to do something, if I want to see how the machines are looking, I can do stack run host backend command equals hostname. And I get an output back. This is a pretty standard SSH output. The first time around it does that. You get the warning and blah, blah, blah. But you actually get the output here. Uptime. Tells you that's been up for about 3 or 4 minutes, which is basically our demo. And that's it. Questions?
So from your stack command, you can also connect an SSH into it?
Yeah, that's actually what the run command is doing. It's basically creating an SSH connection to the particular machine, running something there, and then coming back with the output.
How are those SSH keys are stored and handled?
So obviously there are two aspects to that. Do you mean host keys or user keys? Okay, so with host keys, we actually don't we don't really store anything. We just basically set it up, and whatever the host key you get back the first time you log in, that's the host key for that machine. It's a known host file, and you have complete control of your cluster, so you can remove that without feeling too guilty about it. User keys are interesting because for root, what we do is we push the root's user key to those machines during Kickstart itself. For other users, we actually have most clients that we deal with have their own user management systems off on the side, so they end up using LDAP or AD or something like that. So they have this whole separate key management infrastructure that they prefer to use. So with Stacki, we decided we're going to take a step back from it and say we're not going to handle that part at all. For root, we have to set something up, so we do. For a couple of our other products, like where we have the big data stack, where we want to set up Hadoop, we have to set up a bunch of users like Ambari, and those keys we have to manage, again, for the same reason, because there's no other way to do it. But for anything else, for like standard users, we completely stay hands off of that, and that's actually one of the things that we've been told over and over again to do, because they're like, don't get into our user management. We have ours, we'd like to use it, please stay away from it. So we decided to do that. Yes?
What do we have to do if we wanted to then take this machine and manage them with Ansible or SaltStack?
That's an excellent question. So one of the things is, so one of the people we worked with, so PayPal actually uses Stacki to deploy their infrastructure. And the way they do it is actually use Stacki to do the OS provisioning and all the hardware configuration. And then they put Ansible on top of it. They actually have an Ansible palette. So when they do the installation, Ansible goes as part of their. So we actually have something else called a cart, which is basically a lightweight palette that you decide that you sort of create on your site. So it's a site-specific palette, if you will. So they actually put all the Ansible bits in there, all the Ansible configuration they want in there, and that gets pushed out every time they do an installation. And the first thing that happens when their machines boot up is Ansible comes up. Well, Ansible comes up, if you want to call it that. There's no daemon. Yeah, it's just SSH, right? But exactly, Ansible scripts are basically run as part of their boot process. So the first thing that happens is does a git pull from like their internal GitHub Git repository, pulls a bunch of Ansible files, jobs run on the front end, basically say run Ansible, and they make that system Ansible aware and fully configured by Ansible. Yes?
Is there like a web front end for the front end node?
There is, but it is only part of the advanced commercial package. Yeah. Go
Is
ahead.
there a way to do a script file for all? I mean, other than doing bash, you can put in all the variables to run this particular script with these commands.
Bash is pretty much the one that we have, but there is a Python API.
Okay.
So if you wanted to use Python, you could totally do that. Yeah, go ahead.
is ZFS support available? Or,
ZFS support is actually something people have. So Salesforce uses Stacki to do ZFS. So, and they have 1,600 nodes that they actually wrangle with, and they put ZFS on there, and they've used Stacki to do it. Think about Stacki as a way to get the OS on there, but what comes out is pretty much a very standard Red Hat install. So what you can add into Stacki is the automation part. So if you, let's say you want to configure ZFS on 100 machines, right, and you have this one particular way of doing it, you could actually take all those scripts and all that configuration, put them inside what we called the cart a few minutes ago. It's a site-specific configuration, and then that's it. And you basically make that part of the system. The next time you reinstall that machine, ZFS is fully deployed and installed.
5 more minutes.
Yeah. Questions? I'm actually done with the demo as well. So yeah.
Is there a command you can run to like list your images or?
So we do not do image-based installations at all. So what we actually do is software configuration. So it's basically a standard Kickstart installation.
Or like your groups of palettes or whatever.
That very good. That's an excellent question. And given that you've actually seen a couple of commands now, do you think you can guess what the how to list a palette?
Stack list palette.
Let's try that. Oh my god, that works! Shucks! No way! That just blew my mind! That was actually intentional. The reason is we made the command line to be as intuitive as possible. So, commands, anybody want to get something? But yeah, go ahead. More questions?
So do you have a Ansible module for the front end?
It's so we actually
Python API.
Yeah. So we actually did Ansible palette as a demo. So there is actually an Ansible webinar that I worked with. Have you worked with Justin Nemmers at Ansible at all? I don't know. Okay, but he and I did a webinar together, and then that was actually put out there. Yeah. So we do have Ansible module, but it's not released. Yeah. Questions? Yes.
Can the backends talk to each other any way other than the BitTorrent?
You mean after the installation is over?
Yeah.
Yes, of course. It's a standard network setup. So yeah.
Okay. But as far as like Stacki command or Stacki anything involved Stacki.
No. In fact, we don't even put the command line or the Python library on the backends,
So
and
they
that's.
can't send commands back to the.
Okay. I get what you're asking. So you're asking if there's some kind of a remote API.
Yeah.
That is in development, and in fact, that is going to be released. The next release of Stacki is due in a few weeks now, but the one after that, which will probably be in another 3 months or so, that's when it's going to be released.
Okay. Would that be able to be turned off or?
It's actually going to be a simple REST API, so there's going to be just there's no daemon running on the backend nodes at all. It's just a simple client script that does web API calls to the front end and basically says, I want to run this command. Go ahead.
Do you offer does your company offer internships?
Not at this time, but if you're looking to, please send me a note and I'll see what it can help. Yeah, we're a pretty small company. We are actually looking to hire more engineers. So if you guys are interested in moving to San Diego, please send us a... Yeah. One last thing I wanted to show before I let you guys go is, if I can get to it. That one. That's. Oh, I guess I should have actually done that. Please try it out. It's available for free. There's a Google Groups page. There's a GitHub page. You can download the source code. Take a look at it. There's a wiki along with the source code itself on GitHub. So feel free to actually download it and join our group. We are always looking for new members. So let us know if please use it and tell us how you're using it, so we can get some more traction.
Do you have your slides up anywhere?
This particular set not yet, but I will have it, and it's going to be on SlideShare for sure. And I think as part of the conference itself, you guys put out all these.
Yeah, it's all being recorded.
Yeah.
If it's the same as yesterday, it should be up on the website like late afternoon, I believe they said. Okay.
Yeah, so it should be there. Anything else? Any other questions? We've got a minute.
No, it's the same as yesterday. Today's presentation that we got later today.
Okay, I think we're good. Thank you.